If various plastic processing machines must be supplied with different materials, you need a conveying system. If several hopper loaders are required, the system is normally divided into independent subsystems which are each equipped with a vacuum generator. If one hopper loader indicates that material is required, the vacuum generator starts and the hopper loader is filled. Only one hopper loader per subsystem can be filled at a time. If several request messages are active, they're processed in the order in which they are received. This is how the conventional, normal multi-point conveying system works. However, there is an alternative, a conveying system with a permanent central vacuum. Today, we want to take a closer look at this type of conveying system. A central vacuum system in the technical center of motan-colortronic. As the name suggests, a central vacuum is generated within the system that is accessible to all consumers by means of which the material is conveyed. A vacuum of 0.5 bars, that is half of normal air pressure, normally exists in the vacuum lines. Depending on the utilization of the individual machines, automatically controlled vacuum pumps maintain this vacuum. The advantage of a permanent central vacuum conveying system is that several hopper loaders can be operated simultaneously. Unlike conventional systems, where hopper loaders are always operated one after another, up to 10 processing points can now be supplied with material simultaneously. As a result, considerably greater throughputs can be achieved than with conventional systems. A permanent central conveying system is also relatively easy to extend. The vacuum pumps, of which almost any number can be added, are located at a central point. The system itself is characterized by a large central vacuum pipe running all over the supply points, to which any number of further supply points can be connected. This is how a conventional vacuum conveying system works. Conveyor 1 signals a material requisition. Then the pump starts up to create a vacuum. The conveying process begins. A second conveyor signals a material requisition. The first conveying process continues to run until finished. After that, the second conveyor receives its material. The second conveying process also finishes. The vacuum pump lags behind a short time before shutting off. This is how a central vacuum conveying system works. The vacuum pumps only run if the conveying system's internal pressure sinks below a specified value, for example 500 millibar. Conveyor 1 signals a material requisition. The conveying process can start immediately because the vacuum required is already at hand. Shortly after, Conveyor 2 signals a material requisition. This second conveying process also starts immediately while the first process is still running. What is the advantage of a central vacuum? Power consumption. The pump startup time and run-on time, during which no conveying takes place, is reduced. The more individual pumps work independently at the place of production, the greater the losses due to startup and run-on times, making a central vacuum system worth it. Needs-based. The vacuum pumps of a hopper loader with a central vacuum are controlled automatically depending on the utilization of the connected devices. An accidentally generated excessive vacuum can be stored in the vacuum lines and is therefore not lost for the complete system. Operational safety. Due to the use of several vacuum pumps, a constant vacuum is ensured in the complete system, even in the event of failure of individual elements. Flexibility. New tapping points can be set up at any point within the network. Maintenance requirements. A small number of blowers and filters, which are clearly installed in a central position, reduce maintenance requirements of the system. Parallel operation. In a central vacuum conveying system, several conveyors can be loaded simultaneously, resulting in an overall higher throughput. A central vacuum increases availability and reliability in systems with many consumers.